Our last two motions have to do with objects that are moving in the negative direction. You can tell that because the velocities are negative, and it's going in the negative direction, but we can tell that the speed is increasing. So this object is speeding up in the negative direction. So it's starting over here at time 0. Go ahead and draw your motion map to scale. 1 centimeter equals 1 meter per second. Your motion map should look like this: -2, -4, -6. And now go ahead and draw your change in velocity vectors for each time interval. The change in velocity vectors look like this. We have a change in velocity of -2 meters per second during each 1 second time interval. These velocity vectors make sense because if you take the velocity at one moment in time and add the change in velocity to it, you get the new velocity. So -2 meters per second plus this vector of -2 meters per second gives you -4 meters per second. So the change in velocity is negative. Another way to think about a negative change in velocity is that the velocity is becoming more negative. -4 is more negative than -2. -6 is more negative than -4. So if you think about a number line, this is more negative than this one. Now we want to find the acceleration. So acceleration is change in velocity per unit time. So the acceleration is going to be -2 meters per second every second. And we can represent that by a vector as well. Pointing this direction, has the same direction always as the change in velocity, and that's using a scale of 1 centimeter equals 1 meter per second per second. Now let's take a look at the graphs. So position time, velocity time, acceleration time. Looking at the velocities, it goes from 0 and then becoming more negative. So starts here, goes down here, and that's going to be a straight line. Then acceleration is the slope of the velocity time graph. This has a negative slope, so that's a negative acceleration. You can also see that from the velocity down here, how it changed. You also can see it on your velocity time graph. If you think about slope, in a certain amount of time, the velocity decreased. It became more negative, and so we have a negative slope. The position time graph, let's figure out how we can draw that based on the velocity time graph. Start out with a velocity of 0, so that means my tangent at the beginning is going to be horizontal. This is some kind of negative value, and this is some kind of more negative value. So from a 0 slope, I need to next have a negative slope, which is this kind of direction, and then after that it needs to have a more negative slope. So that's going to be a curve that looks like this. And the slopes here are the values for the velocity. So negative velocity and then more negative velocity. So those are the characteristics of an object that's speeding up in the negative direction. Our last object is slowing down in the negative direction. Go ahead and draw your motion map and your change in velocity vectors and your acceleration vector. And we should just mention if it's slowing down the negative direction, the initial time will be here. So check your motion map. We can see it's slowing down as these velocity vectors are getting shorter. And the change in velocity is +2 meters per second each second. And you can tell that because -6 plus a change of 2 gives you -4. So that change in velocity is positive. So you can almost think of it as these numbers are becoming more positive or less negative. And that corresponds to a positive change in velocity. You also can see that if you take this velocity vector, add to it the change, so draw this vector right here, that would give you the new final velocity vector. Now let's find the acceleration. The acceleration is the change in velocity per second, so 2 meters per second every second, and it's positive. And we can draw the vector using our scale of 1 centimeter equals 1 meter per second every second, and that gives us a positive acceleration. So these two are a little counterintuitive because speeding up in the negative direction had a negative acceleration, and slowing down in the negative direction has a positive acceleration. So it's a little opposite from what we usually think of when we think of positives and negatives. Let's draw the graphs. We have a velocity of -6 to start with, and then getting to 0. And that has a positive slope. So you can see the velocity is becoming more positive. And then for our position time graph, these values tell us the slope of the position time graph. So this is very negative, this is sort of negative, and this is 0. So very negative slope. I could have a very negative slope like that, and then not so negative, and then not negative at all, 0. So that looks like this. And you could also draw that up here. So position is ambiguous in this problem, and both of these curves would give this same velocity time graph.